Now, confounding variables are evil and mess with statisticians a lot. Coincidence, on the other hand, is something that statisticians can deal with very well. This is what statisticians do. We check for coincidence. So, on the back of your T-table is another table. So, pull out Table 11. It says critical values for the Pearson correlation coefficient. And what this table does is it lets you do a hypothesis test really easy. This is like instant hypothesis test, just add water. What are the steps to doing a hypothesis test? There's 5 steps, remember? The first step is to name the null and alternate hypotheses, right? With a hypothesis test for correlation, your null hypothesis is that there's no correlation. This funky P is the Greek letter that means population correlation. So, your null hypothesis is that there's really nothing going on between x and y. Your alternate hypothesis is that there is a relationship between x and y. What's the next step in doing a hypothesis test? Do some math. Okay, we're going to let the computer do that. The computer calculates R. On the test, I'm going to just plain tell you what R is. Step 3 is use a table. So, you need 2 things to use this table. N is the number of pairs, and R is the correlation coefficient. So, if you reject the null hypothesis if the R that you got from the computer is bigger than the table value, ignoring negative sign. Let's do an example. Same null and alternate hypothesis. If the correlation coefficient is negative 0.715, n is 18, and your level of significance is 0.05, let's look at the table. You look down the 0.05 column and across row 18. We don't have to do any n-1 here. This table is easy. Just add water. So if you look down the column 0.05, and row 18, you get 0.468. And to make your conclusion, you just have to see, is R bigger or smaller, ignoring any negative signs. So, 0.715 is bigger than 0.468, so you reject the null hypothesis. Which means conclusion. There is a significant correlation. So if your correlation coefficient from your data is bigger than the number on the table, that means the correlation is statistically significant. It is probably not just a coincidence. Is that an easy hypothesis test? Is that easier than the other hypothesis tests we did? Oh, yes. Oh, yes.